Hey guys, welcome back. So today I'm working on this 3000 watt iPower generator. This one was given to the channel by a friend who says the engine runs, but the generator doesn't make power. So most likely this is a parts machine. Of course, the hope is we can find and fix the problem. So before tearing this thing down, I do want to run some tests, figure out exactly where the fault is, and with any luck, we can get this thing running the way that it should. Anyway, just going over the general condition of this machine, I don't see anything obvious wrong with it. The engine is not stuck, although I wouldn't say the compression feels that great, so we could have issues there. I did take a peek in the tank. It is empty and rust-free, so that is a good sign. And according to the hour meter on the front, we only have 114 hours, so not a lot of hours on this machine. And of course, the power head. Nothing obvious from the outside, although we do have a dent right there, so potentially that is related to the issue we're having. And the exhaust, well, that needs to be replaced. But we're not going to worry about any of that now until we figure out what's going on with this power head. So I say we start there. Let's get this cover off and take a look inside. I'm actually going to start by getting this handle out of the way, just so we're not fighting it, because it kind of blocks access to what we need. So what do you think we're going to see in here? Hopefully nothing, except non-melted wires. Wow. It's actually looking pretty good. You can just see a glimpse of the stator right there. The color looks good. No signs of overheating. The lacing is not charred or broken. So yeah, I give this one hope. Anyway, I want to get the AVR out of the way. That'll give us a better view of what's going on, and then we can actually run some tests through the brushes to make sure we get a good connection to the rotor. And I guess the only other thing worth noting is this bundle of wires right here. It was pinched between the cover and this housing for the ball bearing. Now, I don't see that the insulation has worn through, but if one of these wires failed, that would definitely cause a no power situation, because the other wires, that's what supplies AC in. That's the power source for the AVR that gets rectified to DC and sent to the brushes. So if one of those wires failed, we definitely would have no power. And the other two wires, a little less critical. They are important. They're actually for monitoring the output, so the AVR can make adjustments as needed to maintain the 120. But if one of those wires failed, likely there'd be an overvoltage problem instead of a no voltage. So yeah, let's get this off and run some tests. I'm also going to disconnect these wires so we can test the stator as well. Now there's only two wires coming out of this stator for the main output, and that's because this generator only produces 120 volts. So we're not going to see the two windings like we normally do. Hopefully you can see this multimeter okay. I've set it to measure resistance, and the first measurement you want to take is actually the resistance of your leads. Some leads can have resistance upwards of an ohm, and you want to know that, because whatever that value is that you see, you can subtract that from anything you measure to get the true reading. In my case, the leads have about 0.1 ohms resistance, so I can subtract that from any reading I get. So I'm going to start by checking the resistance through the brushes. Now, I don't know what this rotor should test at. On a larger generator, usually between 40 and 70 ohms. So I'm expecting something similar. And even if I don't know what it should be, I want to make sure it's not a very high resistance or an open circuit. So right now it is open circuit. And when I touch it to here, we should see it measure resistance, and we don't. So it's open circuit. So either we have a bad set of brushes, or I'd say more likely a broken wire on that rotor. So let's get the brushes out. We'll check those out real quick, and then we'll measure directly on the slip rings, see if we can get any reading. Wow, look at that. We just got really lucky on this one. This brush is completely destroyed. And you can see there was some heat. The plastic melted. It allowed the brush to move out of place. And that's why this generator is not making power. So that's an easy fix. We just need a new set of brushes. I guess the bigger question is, why was it arcing? Usually that's caused by some sort of imperfection in the slip ring where the brush kind of bounces and chatters. That creates arcs and, of course, produces heat, resulting in that. So, yeah, I guess we need to get a closer look at the slip rings to figure out how this happened and hopefully how to prevent it from happening again. It's kind of hard to get this angle, but I wanted to show you the condition of the slip rings before I cleaned them up. I think I know what the issue was. If you look at the dark part, the part where the brushes were riding, you can see the alignment's off. The top slip ring had the brush that was actually good, and you can see it was right up on the edge of the slip ring. And if you look on the bottom slip ring, that's the one that had the failed brush, and that dark carbon path is actually right up past the end of the slip ring. So the alignment was actually off. And thankfully, it's off in that direction because we can correct it by bringing it back just by adding a washer right there between the brushes and this end housing body. So we'll add at least one washer to improve the spacing. Most likely we can put one right there as well. This is just a locating pin. But I think if we do that, that should correct the alignment enough to prevent this from happening again. Actually, before I do that, let's just take some measurements so that we know what this should test at if anyone's doing a similar test in the future. So, slip rings are dirty, but it looks like around 52 ohms. Check it to ground, no connection to ground, so that is good. Let's check the main winding. On larger generators, it's usually around 0.2 to 0.5 ohms, and on smaller generators, I've seen them as high as 2 ohms, and that was fine. So we had 0.5 ohms. We'll check it to ground. No connection to ground. And then we have the DPE winding, which is the yellow wires. Usually that's around 1.5 ohms. And we're at 2. That's fine. We'll check it to ground. No connection to ground. And the sense winding is usually just a connection to the main winding. So we've already tested the main winding. We know that's good, and we just verified that that is exactly what we see here. It's just an extension of the main winding. So, yeah, this power head is healthy. It is just a bad set of brushes due to arcing. So, yeah, let's get that plug out. We'll polish up those slip rings, put some new brushes on, and I think we'll be in business. Should I jinx myself? So I'm thinking this is going to be a quick video. Of course, we do have compression issues, possibly. What size are you? Just going to get this ground wire out of my way. Maybe. And there's a look at what they look like now. So they cleaned up pretty well. You know, I didn't really detect any imperfections, any bumps. So I think we're going to be okay as long as we use a spacer to move that alignment over just a bit. So one good thing about Honda clones is that the brushes are fairly interchangeable from anything like this all the way on up to about 10,000 watts. So although I don't have the official iPower set of brushes, I do have plenty of Honda clone brushes. You know, these here are all used. You know, they should work fine, but I do have plenty of new ones. So we'll grab a set of those and try them out. So I found a couple of fairly thick washers that should give us the space we need. So I actually pulled out the new set of brushes. They weren't sitting level with the slip rings, meaning they were kind of at a funny angle. So this old set, as far as I can tell, is fitting in there quite a bit better. And I'm just taking a look with the borescope to try to see exactly where the alignment is. And yeah, that looks pretty good. So I think we're back in business. And make sure the positive goes on the left brush terminal. Just going to drain the bowl before trying to start this. Not sure how long it's been since it last ran, so I don't want to run it on the old fuel that's in here. And since I'm here, I'm also going to compression test the engine. I don't think we're going to have a lot of compression, so this may not start. The fuel that came out actually looks pretty good. There's no water, no bad smell. So it's been run somewhat recently. This engine has a compression release, so the best we're going to see is about 60 psi. And it's never exact, so it could be a little bit more, a little bit less. Let's see what this one comes in at. We're at 50 psi. So actually that should run. So Let's get the spark plug back in. Double check the oil real quick, add some fuel, and we'll try to start it. Plenty of oil. Should be changed. But let's make it earn its oil change. So we are full of fuel. Let's just double check the airbox real quick, make sure there's not a nest in there. And it looks like we're good. So what do you think? Is it going to start? And more importantly, is it going to make power? Let's find out. Ignition's turned on. Choke on. Very nice. We've got power. And that was my big concern going into this. I thought for sure the generator head was going to be bad. And as it turns out, it is a non-issue. So now that I've heard the engine, I think my concern has shifted toward that. And I guess the good news, the engine's not knocking, but it's not sounding well either. You know, when I turned the choke off, the engine was struggling to run. It actually sounded rich to me, like it was getting too much fuel. The odd thing, though, is when I applied a bit of choke, the engine actually smoothed out. So I might have been reading that wrong. You know, potentially I just wasn't hearing it right due to the fact that the exhaust is kind of blown up. So we do need to get that fixed. You know, I have a couple other exhaust systems that might fit in my storage locker, so we'll check that out. You know, I think the carb should be gone through because with the choke off, it wouldn't run right. And you know, my hope was after the engine ran that the engine would feel a little better pulling it over. But it still seems like we have a lot of leak down. So I want to double check those valves. That could be the issue. And that might have been what I was hearing. So I think I'm going to start with the valves. We'll check the clearance and see where it's at. Well, it's definitely earned its oil change. So let's do that now while the engine's still hot, before we move on. Oil looks pretty good. Not perfect, though. I can see a little hint of gray in it. So yeah, I don't think we have an issue. I think most likely it's just been a while, if ever, since this oil was changed. The intake feels pretty tight. Almost zero lash, I would say. Let's rotate the engine though. We'll get the intake open. We'll double check that exhaust. There is absolutely no clearance on that exhaust valve. So that is the issue. I'm sure that's what I was hearing in the exhaust. And that's why when I pull the engine over, it never stops rotating. There is no good defined compression stroke. There's just high leak down. It's all going out of the exhaust. So let's loosen up these lock nuts and reset the clearance on both valves. I don't know what the spec is on this engine, but on Honda clones, 4,000s and 6,000s is a pretty safe bet. Sometimes it's a little higher. I've seen some engines at 6 and 8. In this case, we're at 0, so I think setting this to 6 is going to make a pretty big improvement. That feels pretty good there. And always double check it after you set it, because when you tighten up that lock nut, a lot of times the clearance does change. It usually decreases. And in this case, it did. 6 no longer fits. Let's try a 5,000ths. Yeah, and the 5 doesn't fit either, so we do need to adjust that again. And sometimes if you just tighten that lock nut very loosely, gives you a good idea on where it's going to be when it's tight. And that amount of drag feels pretty good, but I'm going to increase it just a touch. And then tighten it down the rest of the way. Yeah, that 6,000ths feels fine. So I'm going to rotate the engine until the exhaust opens, and then we'll set the intake. So 4,000ths is quite loose. So is a 5. And a 6. But I think some of that's my fault because I already loosened up that lock nut, so I probably threw it out of adjustment. So we'll tighten that up just a bit and double check the clearance before making it fully tight. Yeah, the 4 is now too tight, so I'm going to back off this a little bit. And because the lock nut isn't super tight, we can get away with this, I think. Okay, good. So the valves, I would say, are all set. Let's put the valve cover back on. Now, I did tear the gasket a little bit right there, so if it leaks, we're going to need a new gasket, but I'm banking on the fact that, the other half of the gasket's on the cover. And it should still seal. So let's double check the compression after the adjustment. See if it came up any. Yeah, that is a lot better. We are now at 60 PSI, actually closer to 70. So yeah, pretty good. Should run a lot better. So let's get the plug back in. We'll start it again. See if it sounds any better. All right, let's try this again. Yeah, I wouldn't say that made much of a difference as far as how the engine sounds. I think we are just running lean on that carburetor. So most likely we just need to clean it up, potentially just drill out the pilot jet, and that should solve that issue. That said, I'm glad I adjusted the valves because now when pulling the engine over, I hit a point where we have good compression and the engine stops advancing. So there's minimal leak down, and that's what you want to see. The way that it was, we would have been down on horsepower. We wouldn't have been able to make the 3,000 watts. And of course, if I'd let the engine run for a few more hours, chances are we'd lose compression altogether and the engine would stop running. So that adjustment had to be done. Anyway, let's get the carburetor off and see what's going on in there. Actually, change of plan. I want to fix this exhaust issue before sorting out the carb issues. So I'm going to try to get this uninstalled. The bolts don't look too happy, so we'll put some penetrating oil on it. And once we get it off, I'm going to make a trip to the storage locker, check out what options I have. We'll bring them back here and try them out. All right, let's see what we have here. I have a shelf full of exhaust systems from generators that didn't make it, and I know one of them for sure came off a 3000 watt Predator, also a Honda clone like the engine we're working on now. So this is that exhaust. With any luck that will bolt on. And I was hoping we had another, but we don't. These are all for different engines or for larger Honda clones, so none of these others are gonna work. So this one is our only hope. So let's bring it back. We'll try fitting it, and hopefully it fits. All right, hopefully this fits. Yeah, it's going to bolt onto the engine fine. And the bracket here on the end, it looks like it lines up properly. So I think we're in business here. This is pretty much a perfect fit. The bracket right here on the exhaust lines up perfectly with the bracket on the stator to support the exhaust on this side. And of course on the engine side, it is perfect as well. So this is a good replacement. I think the only glaring omission here is that there is absolutely no heat shielding. And on the Predator that this came from, there was an outside shield just to keep people from touching the exhaust inadvertently, but there was nothing kind of between the exhaust and the stator. So ideally, we would have something there just to help the stator live the longest life that it can. And of course, with no protection here, it's a little bit more dangerous and may not be safe for the tank, although we do have a fair distance there, so it might be okay. But if possible, I would like to reuse this heat shield on this broken exhaust system. So let's get the bolts out. We'll try to see if there's any way we can make that fit onto here. So it does fit. I think the issue is just going to be the mounting hardware. So, potentially I could grind those welds off, relocate these brackets, but I think the alignment is going to be really tricky. But, I don't think we have another option here. So, yeah, let's try to get these brackets off, and we'll just move them on over to the other exhaust. So I think the plan here is just to weld one of these brackets on at a time. Without a jig, this is not going to be an exact science. So it's going to be a little tricky getting all the holes to line up. So, worst case, we can always elongate some of the holes like these right there. And one way or another, we'll get it to fit. Good enough. Doesn't need to look pretty. So I am going to have to elongate that hole. This exhaust system's a little bit shorter, or I should say not as long. So in order to get the spacing to match those holes, I'd actually have to mount the bracket up here, which I don't want to do. So I think that'll be good enough. Okay, we got 2 down, 4 more to go. So I'm going to spare you some of the detail. I'm just going to cut off the additional brackets here, weld them on, and yeah, hopefully it goes as well as these two did. Almost there. 2 more to go. Gonna put some high temp paint on all the areas I welded and sanded. Now this whole thing is gonna be covered by the heat shield, so I'm not too concerned about making these welds look perfect, but I do want to protect it against rust. And last but not least, we need to get the carburetor to run the engine a little bit better. Now, I'm almost 100% sure we just need to drill that jet out, but I think it would be prudent anyway just to get the carb off and take a look. Make sure it's clean, and if it's still running poorly, then we'll drill the jet out. All right, let's take a look in here. Yeah, pretty clean in here. So that is kind of what I thought I was going to see. So, I'll get the jets out anyway, make sure they're clean. But I think at this point, we just need to drill that pilot jet that's right on top here. So that should fix this issue. I don't even think this carb needs to go through the ultrasonic. Although I might put the bowl back on and just use a bit of carb spray. We'll clean all the dirt off of the exterior. Emulsion tube looks pretty clean, except for the dirt that I just got on it. The main jet looks pretty good. This is the idle set screw. This engine doesn't idle, so do not drive the screw in too far when reassembling it, because if you do, you could over-rev the engine. The only purpose this serves in this application is just to hold down the pilot jets. The pilot jet is just pushed in. It has an O-ring, and that screw holds it in place. Yeah, and that's it. There is really not much to this carb, so let me just go through everything real quick, make sure it's perfectly clear. We'll clean out that little bit of debris in the bottom of the bowl, and then we'll put it back together. We'll clean the exterior, drill out the pilot jet, and give it a try. You want to make sure you get anything rubber out of the way because the carb spray will swell it up and then you'll have to replace it. Yeah, I believe the stock size on this jet is a number 79. I'm just going to double check it. So an 80 fits. And actually a 79 does not. So we'll start with the 79 bit. And then we'll go to the 78. And we'll give that a try. Yeah, 79 actually went through very quickly. So if it wasn't a 79, it was just barely not. So yeah, I might actually go to 77. Okay, we're through. So it is now number 78. And I'm fairly certain we are going to have to go to 77, but I think we should try it like this first, because once you drill it out, you can't put the material back. So good. Let's get this reinstalled. We'll clean up the exterior and try it out. I was just starting to clean up this air box, and the plan was to drill out right here where this barb used to be that holds the tank vent. Unfortunately, we have bigger issues here. There's some damage down here, not a big deal, but the bigger problem is actually up here. We're broken right there and right there. So with the cracks where they are, that is completely bypassing the air filter. So this air box, unfortunately, is junk, and I don't have any others, so I am going to have to order one. So for now, we'll just bolt the carb on, test it like that, and get a new one of these ordered up. And we'll put the choke lever on, but it's actually the airbox that keeps it in place. So without the airbox, most likely this thing's going to go flying as soon as the engine starts. All right, let's give this a try. That was it. It was just a restricted pilot jet. So this time, it started first pull. I was able to turn the choke off right away, and that governor arm was rock solid steady. So, yeah, I can't say I'm that surprised. This is actually the 6th Honda clone in the 200cc family that I've had to drill that pilot jet out on. You know, 2 of the carbs are brand new, surging out of the box. And in another case, I actually had a brand new engine with a new carburetor, and that was surging out of the box. So if you have a Honda clone kind of in this size and it's surging, chances are you do need to drill out that pilot jet. In this case, a number 78 fixed it. You know, sometimes I do have to go down to a 77 and maybe a 76. Anyway, the carb issue, I would say that issue is no more. And the exhaust also sounded pretty good. So we are getting very close here. We just need to place an order, get a new airbox installed, and then we can get this outside and put it to the test. All right, we're in the home stretch here. The new airbox did show up today. It is more or less a perfect match to the one that was on there. This one actually also has the fitting for the tank vents, so no need to drill to get that line installed. But before we can get the airbox installed, there is still the broken piece in here. So let's pull that out first, and then we can get the new airbox on. That's interesting. There's a tube inside of a tube. There's actually another one right there, which it's going to be hard to get out. So let me try threading a screw in there, see if I can use that to pull it out. Oh, that was easy. And this is a foam filter and does require some oil. So you just pour a bunch on the filter, kind of work it in, and then use a towel to squeeze out the excess. So unfortunately, this line, the inner diameter is larger than the outer diameter right here. So I need to either swap the line out or increase this outer diameter. And I already double checked. The fitting down there, it's pretty large. I'd say it's a 5/16 line. And I don't have anything to adapt a 5/16 down to, I would say, a 3/16. So I think what I'm going to do instead is just use a bit of shrink tubing to increase this outer diameter to give something for this clamp to hold on to. I think we need one more. But not that one. Perfect. Yeah, unfortunately, there's really no way to move these wires anywhere else due to their length. Ideally I would move it kind of out of this area because when the cover is installed, I wouldn't say it pinches the wires, but it definitely holds them fairly snug in that position, which, yeah, isn't ideal. And I guess it would be potentially even worse if these wires were longer, because then they could get sucked in and chewed up by the rotor. So I'm going to have to say that this is going to have to be good enough. All right, let's see what this machine can do. Now, it's rated at 25 amps, which is 3,000 watts. So we have 3,000 watts of load on standby. The control panel only had one plug in it, and it's a 20 amp plug. Of course, I'm not sure what the circuit breakers are rated at. There are two breakers right here, but I don't think they have any indication of what they are. So rather than trying to pull 25 amps out of that, I have this adapter right here that adapts this 30 amp plug into the type we need. So we can run the space heaters. So we'll get that plugged back in. We've got the fuel plumbed in. So let's get it started. We will check the outputs and see if we can get to 3,000 watts. There's a lot of glare, so I'm going to put this up on the screen. I wouldn't say the sine wave looks great. It's pretty ripply and not a very smooth transition from peak to peak. The THD, we're at about 7% without a load. There's a look at the sine wave. Smoothed out a bit, but not quite the right shape. And the THD jumped up quite a bit. We're now at about 21% THD. The sine wave looks about the same. The THG did jump again. We're now at about 24.5% THD. Well, believe it or not, this was supposed to be a parts machine. The friend that gave it to me with that in mind, thinking that I could use it to save another machine. And instead, we actually used the Predator exhaust to help save this machine. You know, in the end, we got pretty lucky on this. It only needed a set of brushes and a valve adjustment, and now it's running at 100%. We had no issues pulling the rated load of 3,000 watts. The voltage and the engine speed did well, and the distortion wasn't great, but it is typical on something like this. Usually at full load, you're going to see around 20 or 30%, and we saw right in the middle at 25%. So yeah, this thing is doing a pretty good job. So at this point, I am done. You know, I'm going to let my friend know that I was able to save this, and he is welcome to it back if he wants. So I hope this video helps someone. Thanks for watching.